Hi, folks. This is meteorologist Don Paul on my YouTube channel, Don Paul Weather Plus. Haven't done one in a little bit. And this one will have a little staying power since I'm going to take a break for almost 2 weeks. But this is about climate, not immediate weather. And the basic topic here is why we know it's us and not natural variation in the climate that's causing the mean warming of the globe. And by mean warming, I mean when you average up all the surface temperatures and the sea temperatures, on average, the globe is warming up. There's absolutely no dispute in this, no matter what non-scientists, denialists try to tell you. But we've seen in the last month and a half some really extraordinary episodes of warming in the far northern hemisphere. Many of you already heard that last Thursday was the hottest day in Paris history, with a high of 109, the hottest day ever recorded in the Netherlands, Germany, and Belgium, where records go back to the 1840s, which is even further back than here in the U.S. And this is a look at the upper air over the northern hemisphere in Europe as of about Saturday. And I can just tell you that this little contour, we may be able to read that number 591, to see a hot ridge of high pressure centered over northernmost Sweden is simply mind-boggling to atmospheric scientists, which include not just meteorologists, but physicists and also, of course, climate scientists. And this may be unprecedented. It's definitely unprecedented in the years I've been doing meteorology. And this kind of heat with temperatures actually reaching the low 90s well north in Scandinavia is not something that has been happening in the past over and over again. Now, I want to tell you a little more about this pattern. This is the same hot ridge which late last week was centered farther to the south, and that's when we had those 100 plus temperatures over much of Western Europe. London, the metro area, had several recorded highs of 100 degrees, which is close to the hottest London has ever been. This is not just coincidence. So how do we know it's human activity and not natural variations? Well, we do know that the Earth has had periodic glacial periods and warm-ups before the Industrial Revolution. So a lot of people who are either purposely attempting to mislead the public or who simply don't know any better said we've always had these warm-ups and cool-downs and this is nothing new. Yes, it is. For one thing, the past warm-ups and cool-downs have been associated with an extremely complex variation in the Earth's orbit. The Earth's orbit is not just plain circular or flat plane. There are several different eccentricities in the Earth's orbit which have different cycles. The Earth's orbit goes from virtually a perfect circle to an ellipse over a 100,000-year period. Now, when it goes to an ellipse, it changes the amount of solar energy received at the farther end of that ellipse, and that has helped in the past to trigger ice ages. The Earth also has a wobble in its axis, and that cycle takes 19 to 26,000 years, where the North Pole points to Polaris, and then the wobble sends it back toward Vega. And over that 26,000-year period, that causes a tremendous variation in the solar energy received. And then there are other changes in the Earth's, it's called obliquity. Don't worry, this won't be in the Blue Book, another 41,000-year cycle. Now, all of these wobbles and cycles are well monitored and well predicted and are part of something called the Milankovitch cycle, which has been peer-reviewed. This was a Serbian engineer who came up with this and is now generally accepted in the atmospheric and climate sciences. And it is known that these Milankovitch cycles have been the primary forcing mechanism in past warm-ups and freeze-ups. But we also know that the current stage of the Earth's orbit at this time, over the last century plus, would actually be linked with global cooling. In other words, where the Earth's orbit and wobbles and eccentricities are is in a part of its many cycles, which cool the globe. Well, the globe's not cooling. We also, in the shorter term, have had a sunspot minimum that's been going on for quite a while now, and there is a hypothesis that low sunspot activity also causes at least cooling over a period of several decades. That hasn't been happening. And there are other oscillations here on the planet which can change regional weather for several years at a time. But all the natural variation elements, including how much solar energy is being received by the sun, that's measured exquisitely every day around the globe by industrialized nations, is not increasing. In fact, there's been a slight reduction since the 1980s. So there is nothing in nature to explain the warming which has been occurring. There just isn't. And believe me, it's not for a lack of trying to find natural forcing mechanisms. And we'll go over a shorter period of time here. The maximum warming on the globe has been exactly as predicted by 1980s climate models, when those models were still pretty new, the Arctic. And the reason for that, it's not too complicated. When the Arctic Ocean was colder, we had more highly reflective ice with a white surface. It's called albedo, the reflectivity, which reflected much of the sun's energy back into space. But we knew as the globe warmed, the place that would warm up the fastest would be the Arctic Ocean. And that's because as the ice melted, there was more replacement of that reflective albedo by absorptive dark ocean waters. And it creates a feedback mechanism which has been going on for decades now. And that's evidence here in this graph. This is from NASA, 1980. The peaks are the summer months, the valleys are the winter months. But you can see if you drew a median, it's been going up. Not perfectly linear, but it's been going up from 1980 until right now. And it's now, for this year, the warmest in instrumented history, which includes satellite imagery going back to 1979. And that's part of the reason we have seen low 90s as far north as northern Sweden. And there is no reason to expect this trend to go back the other way, because the more dark ocean water you have, the less ice there is during the summer months, and the longer the melt season lasts, and with a shorter freeze season, the ice that redevelops in the cold months doesn't get to stay there as long, and it's thinner when it comes back. And when it gets thinner, it melts more quickly the following season. And then you have this feedback that goes on, and it continues to accelerate in a non-linear fashion. Now, when the Arctic gets warm, like it is now, and the temperature difference between the Arctic and the mid-latitudes is less than it was 40, 50, 60 years ago, that weakens the jet stream and allows it to buckle. And in the winter, that can cause extreme cold in some locations, while other parts of the globe are extremely warm, because instead of a flatter flow from west to east, you get this high amplitude with these big dips and huge ridges that form up north. And that is due to the weakened jet stream, which is directly linked to the warming Arctic, which is directly linked to humankind's use of fossil fuels and other things in human activity which add to the Earth's atmosphere, trapping more infrared heat in the nighttime hours. And there is the bottom line. It is us. There is something that can be done, a set of things that can be done to lessen the total impact of future warming. So I'm not here, and most more learned scientists are not here to tell you, throw up your hands and give up. There's no doubt that warming will continue, but there is a way to lessen its severity by more rapidly getting rid of fossil fuels. And that's not something where you can snap your fingers and it's going to happen in a couple of years. But the difference between the best case scenario, which is none too good, and the worst case scenario, where we continue the burning of fossil fuels unimpeded, is a huge difference. The worst case scenarios would be calamitous for much of the globe, especially the northern hemisphere. The best case scenarios will still have huge impacts on coastal areas that are vulnerable to the sea, the rising sea levels, which are a direct result of both ice melt from Greenland and the glaciers, as well as the oceans actually heating up. And when the water heats up, it expands. The rising sea levels, the difference between a couple of feet sea level rise and 6 to 8 feet sea level rise could be the difference between having to evacuate tens of millions of people from coastal cities. So the idea that it's too late, there's nothing further that can be done, there isn't much evidence to support that kind of pessimism, but it is up to us. Now, I'm not a social planner, that's not my area of expertise, but that's the bottom line on why we are now certain that human activity is the primary forcing mechanism for the ongoing warming. And when someone tries to tell you that it's just natural variability, as it's always been going back to before the Industrial Revolution, there is no evidence to support that position. It's wrong. So with that very opinionated YouTube video, I hope some of you will still deign to hit the subscribe button. That's what's going to keep this channel going. I haven't seen a whole lot of new subscriptions. Some of that may be my fault. I haven't done as many of these or done more interesting videos, but I'm trying to keep the content important. So talk to you within a couple of weeks or so, and enjoy this summer, which will grow a little more comfortable by midweek this upcoming week. I'm recording this on Monday, the 29th. Talk to you soon.